Good afternoon, all, or good day from where you are watching or where you are listening to me. Um, Supposedly, I tried to check through what we've done so far, and I've found out that we've covered pretty much, um, ranging from checking the order of numbers, fraction, decimal approximations, logarithmic, arrangement and sorts. We've done indices, logarithm sorts, number bases, set theory, binary operations, inequalities, polynomials. And we've done also a bit of geometry was done earlier. And then I think we also did a bit of differentiation. But today, what I will just do is a bit of everything in a way. I'm going to be summarizing calculus, basically differentiation, and I'm also going to give a brief introduction to the basic ideas that you can have under um, integration. Okay, so we've already established that our differentiation is the same thing as dy dx. This is how to find differentiation dy dx. They may decide to actually, you might be asked to, it can be represented differently. If it is not dy dx, it's the same thing as f prime of x, all right? They can write ddx of f of x, all right? All these three representations are also pointing to dy dx. And for the sake of the exam you are writing, nobody will ask you to prove from the first principle. Definitely, yes, nobody will do that. So you should know that if your y is equal to ax raised to power n, this is the original function in initial form, then your dy dx will be equal to n multiplied by ax raised to power n minus 1. You have that. This is the consequence of any function in an initial arrangement, yes. And also you should know that there are rules that support this. We have addition and difference rule. We have what we call multiplication rule. Another word for multiplication rules is product rule. All right, when you say find the product of 2 and 3, it means you have to multiply 2 and 3. So we call it product rule. We also have what we call function of function, or what you can simply refer to as a chain rule. Then we have what we call the quotient rule. That is when it is division. So I'm just going to give you a brief introduction to each of that. Then I hope a few minutes that we have be able to go through that. So possibly after that, I might just want to touch briefly on some other topics if we have that. But this lesson of today is a bit of calculus revision, and if we have enough time, we can quickly launch into other topics. Okay, so here if y is equal to 2x minus 3 over x squared, just decide to go this far. Our dy dx, you can rewrite this before you differentiate to make your life easy for you. You can rewrite it as y is equal to 2x minus 3x raised to power minus 2. Yes, from the law of indices, it is allowed to write this way. So you are going to follow it. You are going to follow this arrangement, because I'm taking this screen away now. You are going to follow this arrangement. I don't know. I would have loved to use my screen probably from a laptop. I don't know if that arrangement is going to work for me now. Let me not just waste time. Let me quickly move on. So let's differentiate this. 2x minus 3x raised to power minus 2. Okay. So our dy dx will now be equal to 2, because the x you have is raised to power 1. So 1 times 2 will remain 2. 1 minus 1, then minus 3 into bracket minus 2. X raised to power, sorry, this line I have to continue like this, minus 2 minus 1. That's the rule. So our final answer will become 2. X raised to power 1. 1 minus 1 is 0. So anything raised to power 0 is 1. So 1 times 2 will remain 2. So we now have minus 2 times minus 3 will give you plus 6 raised to power x raised to power minus 3. So this will be the derivative. That's what we call it, derivative of what you have earlier. Okay, let me just quickly show you back. This is the original question here. And then by the time you do this, following this arrangement, which is the law, you are going to eventually have this as your answer. Each term must be differentiated using the law independently. That's what you have here. Okay, so I want to give you a more, okay, let me just now, so this is just the basic rule. Now let's go to maybe we should just differentiate this again. We have what we call higher order differentiation. In case you are given, these are things that can come up in exam. We have what we call higher order differentiation. That is, this is a function. They can ask you to differentiate this value again. They can ask you to differentiate this value again. So in case they now ask you to do, so that one is called d square y dx square. That is second derivative. It is called second derivative. So you are still going to follow the procedure. But at this time, this number that you have here now becomes a constant because it has no x variable. So automatically, derivative of a substance, of a constant is a 0. Derivative of a constant is a 0. So it means this one will disappear in our answer here. We are now going to focus on 6x raised to power minus 3. And then the power will multiply the number. So minus 3 into bracket 6, then x raised to power minus 3 minus 1. And that gives you minus 18 all into bracket x raised to power minus 4. That's what you are going to have. Okay. So minus 18 x raised to power minus 4 is the answer. They can ask you to differentiate it the third time. Just follow the simple rule that you have had in the previous screen, and it will help you. Just continue like that. The power will multiply the coefficient and the power will reduce by 1. That's all you need to do for each term that you have that has x variable. So that's what you continue to do. They can ask you to differentiate the third term. That third time, that is d cube y dx cube. Okay, instead of writing it as d square y dx square, they can also write it as f prime prime of x. What it means is second derivative. So for f prime 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 of x, this third derivative, that is d cube y dx cube. All right, so you can have that. But so having that, let me quickly now go away from here. Let's talk about the reversal procedure. The reversal procedure is called integration. Integration is reversal of integration. Differentiation. Integration is reversing differentiation. So if you have your formula as y is equal to ax raised to power n, then integral of y with respect to the x, this is how we write it, will now be ax raised to power n plus 1 all over n plus 1. So I will need to box this as a very important formula to follow. And I will quickly use, but when you are doing this, put a plus C very important. You had a constant. Yes. Let me rewrite it. So generally what you are going to have is ax n plus 1 all over n plus 1 then plus c. The reason why you are hiding the c is that it will take care of the constants that disappear in your procedure of differentiation. So I want to call back the example I used just now, where I said I've differentiated up to minus 18 x raised to power minus 4. So if I want to find the integral of this, just like what I have here now, the power is minus 4, the coefficient is minus 18. So integral of y with respect to dx will give me minus 18 x raised to power minus 4 plus 1 all over minus 4 plus 1. That's what I'll use. Then don't forget plus c. Let me use, so this will be plus c. Our c will just be in one corner here. What I wanted to write is plus c. So let me see if this one can move back a bit. Okay. Then I will now have plus c. Okay, I think we can manage that. I just don't want it to conflict. That's what I'm trying to do. Plus c. Yeah, it works. Okay, so plus c. So we now have this. And by the time you simplify this expression, minus 4 plus 1 will give you minus 3. So you are going to have minus 18 x raised to power minus 3 over minus 3. And this will now give you, of course, minus 3 will cancel minus 3 here. This one will cancel this. So what you are going to have left is 6x raised to power minus 3. That's what you are going to have. And that was what you integrate. That was what we differentiated before. Don't forget our final answer must be plus c. You can have this. I can so go ahead and integrate this one the second time. I can integrate this the second time. And in that case, this is how you write it. Integral of y with respect to dx. That's how you write it. Integral. So when you are integrating several times, you have to repeat that sign of integral. So it will be integral of y with respect to dx. That means we are integrating the second time. And that will give you, now you have a c, and so this will now give you 6x minus 3 plus 1 over minus 3 plus 1. This time around, there is a c in the original equation you have, so you have to consider it, plus c x raised to power 0 plus 1 over 0 plus 1. You have to consider that because c times 1 means c times x raised to power 0. Anything raised to power 0 is 1. So you are recalling that value. So this will now give you 6. So you are going to have 6x raised to power minus 2 over minus 2 plus cx over 1, then plus, I can use another constant. I should not use this c again. C is just a constant, so you have to derive because I'm integrating the second time. So I'm going to use any other constant. Let me use k this time around. So all of this now, of course, you know that minus 2 will cut 6. This one can go. So what I will have left is I'm going to have minus 3x minus 2 plus cx plus k. K being a constant of the second order integral. So that's what we have there. And I need you to watch all this closely. You will see, let me just quickly recall something to you. Here, you will see that we see minus x. That 2 is what we cannot now, as we are using as CX. So you can see that we differentiated twice and now we integrated twice. Are you getting it now? So this is what will happen to us. So you do all that. Okay. So it's fine that we finally end up here. So please, I need you to note that. When you are doing all this now, it is called indefinite integral. This is called indefinite integral. When you are doing definite integral, you'll be given a particular number range to work with. That is definite integral. I will just give you an example of that before I move away from here, because I need to move away fast. For definite integral, you'll be asked to do something like this, maybe from 0 to 2, to differentiate, to integrate 3x squared plus 5. Between 0 and have what we call definite integral. Let me quickly just solve this so that we know what we are saying. The first thing is to integrate. When you integrate by normal formula, this will give you Oh, okay. So sorry for that. I think there's a loss of internet there. So what I was just trying to do was, I need to differentiate this guy. I'm differentiating 3x squared plus 5, and I'm differentiating it from 0 to 2. I will explain what that means. So the first thing is differentiate what you have as your function. You need to differentiate this guy. So when you differentiate this guy, what you are going to have, okay? All right, so what you're going to have is that it will give you 3x 2 plus 1 all over 2 plus 1, then plus 5 x raised to power 0 plus 1 over 0 plus 1. So you align it like that. Under definite integral, you don't need to put a constant because you have been given a definite category of number to work with. We are working from 0 to 2, so we don't need to put any constant. That's the difference between indefinite integral and definite integral, and that's why I have to come this far. So here, your final answer, you are still going to put it between the stipulated values, 0 and 2, okay? So this will give you 3x raised to power 3 all over 3, then plus 5x, because anything 0 plus 1 is 1. So, and when you divide anything by 1, you have that. So this is what you have. And we are also differentiating that between 0 and 2. Okay, this one will also be here. Okay, so it is at this point that we have done our integration. We'll now put the values of 0 and 2 into x. Anywhere you see x, you put 2. Anywhere you see x, you put 0. Then you separate it by subtraction. So what it means is that 3 into, give me a minute to take care of my screen. Okay. So that will be 3 into 2 all raised to power 3 over 3 plus 5 into 2. That one is there. Then minus 3 into 0 all raised to power 3 all over 3 plus 5 into 0. Okay, 5 into 0. I can just put it. Let's manage it that way, please. So 2 raised to power 3 will give us, I can cancel this, of course. This can be cancelled. Let me just cancel Let me just cancel this. 3 will cancel 3 here, so we may not bother about that. So that will be 8 plus 5 times 2 is 10. 8 plus 10. And here, of course, 3 will cancel 3. So 0 plus 0 is nothing. So the answer at the end of the day will be what? From here, the answer will now be 8 plus 10. That's what you have in the first bar, minus 0 plus 0, because 0 raised to power 3 is 0. So you have 18 minus 0. So your answer is 18. Under definite integral, that's why it is called definite. You will always get a number. You always get a number. So please watch this several times and be sure you understand the method we have used for the integration aspects of it. I want to believe they should not stress you more than this under any circumstance. Okay, definitely. I've given you application of differentiation in one of our classes. I've told you that when you differentiate a displacement, what you have is velocity. When you differentiate velocity, what you have is acceleration. The same thing happens to the reversal. When you integrate acceleration, you have velocity. When you integrate velocity, you have displacement. So you need to note all that too. It's just like I said, integration is the reversal of differentiation. So once you are familiar with differentiation, reversal of it is the integration. Okay, so I think on that note, we are good to go. You can practice more questions to be sure you know what you are doing. You are free to still refer back to me through the general platform to ask your questions. So I want to quickly also touch on, okay, looking at the topic here. I think we have talked about sequence and series, AP and GP. Let me quickly talk about it too in a few minutes so that we can close out. So AP, GP. Now, for each of these, you know that there are two things they will be asking for. I'm just going to relay the formulas for you. If I can recall any topic or any particular question that is necessarily supposed to be solved, we'll look at it together. So under AP, we talk about sequence, linear sequence, and then we talk about series. I wanted to write CE, okay? Linear sequence and linear series. Series is repeated addition of sequence. The same thing for this. Under GP, we have sequence and series. So under sequence now, we talk about nth term. So let me quickly go for AP. Nth term is given as A plus N minus 1D. Your Tn is the nth term. Your A is the first term. Your N is number of terms. Your D is the common difference. Let me come again. Tn is the nth term. A first term. N number of terms. And then D is the common difference. So having noted that, you can be given some numbers and be asked to find, you can be asked to find a particular term. Like if you are given something like 2 minus 5 minus 12, they can, and then they ask you to find the 10th term. So you need to know, how do you get the common difference? How do you get the first term? Of course, this is the first term. Your first term is the first number that appear in the sequence. A sequence is a pattern of number that follow a particular way of addition or subtraction, because it is AP. AP simply means arithmetic. From the word arithmetic, it means you either add or subtract. Basically, that is what arithmetics means. All right. It is also called linear because it follows a subtraction or addition, which is straightforward. So it is easy to pick the first term. The first term is 2. To know the common difference, you need to check what's the common difference between 2 and minus 5. What's the common difference between minus 5 and minus 12? So once you are able to get that, you won't have problem. All right. And from here, at this level of preparing for JAMB as a mathematics student, you should know that the common difference is 7. Yes, minus 7 rather. Common difference is minus 7. Yeah, if I add minus 7 to 2, I'll get minus 5. If I add minus 7 to minus 5, I'll get minus 12, and then continuously like that. So it is easy to just make use of that. So your D will be given. So my A is equal to 2. My D, common difference, is equal to minus 7. Now, your N depends on what you were given. In this case now, I'm just giving a random question. They say find the 10th term, Tn, that is T10, where your N, and the value of N that you have here is still the same value of N that you are going to have here. You can see the N here and the N here, they must tally. So N now will become 10. If N is 10, then Tn becomes T10. These are the things you need to note. And if you use the formula I gave you, you'll be able to get the 10th term without having issue. All right? You'll be able to have the 10th term without having issue. So we can just try out and see what the 10th term will give us. So T10 will now be equal to 2 plus 10 minus 1. We have identified our D as minus 7, minus 7. So it's easy for me to say that you are going to have 2 plus 9 into brackets minus 7. 10 minus 1 is 9. So you have that, and that will be 2 plus 9 times minus 7 is minus 63. Plus times minus is minus. So you have our answer to be minus 61. So this is the 10th term. If you continue that, we should get this. All right. And without wasting time, because we have about 10 minutes left, so I will just quickly rush through that. Sum of nth term, like they say, okay, add all the terms together up to a particular term. That's what we call sum of the nth term. So the formula for sum of nth term, Sn, can be given as n over 2 into bracket 2a plus n minus 1 into d, or n over 2 into 2a plus l, or just a plus l. Yeah, a plus l. It's not 2a, it's just a. Yeah. Where L, it simply represents the last term. So Sn, it depends. Like now we found our last term. Let's say we are talking about addition of the first 10 terms. We found our last term, that is the 10th term, to be minus 61. So instead of trying to go long route, we just put the value of that last term in, which is the 10th term, where n represents 10. If you put it here or you use the conventional formula, you get the same answer. So that's that. You need to work on that. So let me quickly go to GP. GP simply means geometric progression. I've told you that this one, which is called AP or linear progression, follows addition and subtraction only. There is another one called general sequence, which you can manipulate your way through. But this one it has a strict way of operation. Linear sequence is addition and subtraction only, while geometric sequence, or what we call geometric progression, or most times it can also be referred to as exponential sequence. All right, it follows multiplication or division. It cannot be the two at the same time, or it can also be the two at the same time. It depends, because you may have something like times 3 over 2, which is both combination of multiplication and division. So it depends. Your ratio can be that crazy. You just need to manage yourself all through it. So I'm going to give you some basic thing about it. So for GPTN, geometric progression, the nth term is given as ARN minus 1. Please note that the power of R does not affect A. It is only R that is raised to power n minus 1. A lot of students make that mistake by multiplying AR with the power. No, it is only R that has that power, not A. All right. And just like I explained, in this case, we don't talk about difference, we talk about ratio. Ratio because the terms follow either multiplication or division. The terms follow either multiplication or division, so we use ratio to it. All right, and A retains the same meaning, first term. N means number of terms, so it is easy for us to relate with that. Very, very easy for us to relate. So if you have something like 2, 6, 18, blah, 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 you can easily identify with this. What can you multiply by 2 to give you 6? What can you multiply by 6 to give you 18? You know, that's how to get common ratio. So your A is 2, and then your common ratio, as you can glaringly see in here, you can see it clearly. How do I put clearly? It is glaring, but it is also clear. As you can clearly see it is 3. Because when I multiply 2 by 3, I'll get 6. Pick that 6 again, multiply it by 3, you get 18. And by the time you multiply 18 by 3, you should get the next term. So it is a common ratio. That's why we use the word common. It is something that is regular, all true. All right. So having seen that trend, you should be able to calculate probably the 5th term, the 6th term, the 10th term, depending on whatever they want to calculate. All right. Let's just try the 5th term here. T5, where n is 5 now. T5 is equal to AR5 minus 1. All right. So that will give you 2 times, my R is 3, 5 minus 1 is 4. So what I have is 2 times 3 raised to power 4 is 81. So I have 81. And when I multiply 81 by 2, I'm going to get 162, I believe. That's what should give you. So you can try it and check whether we are in correct order. You can multiply 18 by 3, it will give you another thing. Multiply that by 3, you should get this. That's in the 5th point. Now, what we want to check now is sum of nth terms. There are 3 general methods or formula that represent the nth term. There are 3 general formula that represent the nth term. And I'm going to be giving you all the 3 general formula. The first one says that Sn, sum of nth term, is equal to A into bracket R raised to power n minus 1 all divided by R minus 1. The condition for this, there is a condition. The condition is that R must be greater than 1. R must be greater than 1. Then the second one, that's the condition number 1. For this one, note, R must be greater than 1. For the second one, Sn will now be equal to A into bracket 1 minus R raised to power n all over 1 minus R. The reason why some people will solve a question under this topic cannot get it is because they don't know that there is a condition attached to the nature of R. all right? In this one, the condition is that your R must be less than 1. And you can use, I'm using absolute value here. You can see that I'm using absolute value. It doesn't say that your R can be a negative. No, we are not even after the negative or positive. We are checking whether when you find the absolute value will always return a positive value. Whether it is not a fraction like 1/3, 1/4, 1/6, 2/5. When you have your R in that, you use this second formula. But when you have your R to be 2, 3, it can even be 3/2, which is 1.5. It's still greater than 1. It's a fraction, no, but it's still greater than 1. So you have to use the first formula. Those are the two conditions that you need to be careful about. And then now, the third formula is called sum to infinity. In this case, your R is always less than 1. Sum to infinity is just A over 1 minus R. So these are the three formulas. In this case, automatically your R is less than 1. Anytime you are looking for sum to infinity, your R must be less than 1. Yes, your R must be less than 1. So at this point, I think I have to stop. We have just few seconds to the end of our 40-minute class. So please take your time to go through each of these and practice questions. I don't want this thing to end abruptly. So I'm going to end myself and then wait for the time to off so that we can exit this class. But we've done pretty well for ourselves. You can go through the slides several times to be able to grab the understanding. Thank you very much, and I wish you best of luck in your exams. Bye for now. Yeah.